this one as well. I'm sorry, it was right. It was right. Okay. Maybe talk to somebody nearby and see if you have some idea what these numbers are. So yeah, most of these are the same trick, I have to say. They're all, except for the last one. The last one is not. Okay. Okay. Sri Chunchun, do you have some idea? No? What if I read it like this? Does it look more familiar now? So remember, this is something to the n over n factorial. The sum of blah to the n over n factorial. Right? So remember, e to the blah is the sum of blah to the n over n factorial. So what's this? This is going to be e to the 3 over 5. Okay. I should say that this is not really pronounced blah. This is a real letter. This is pronounced zeta. Zeta or zeta. Okay, what about this one? Anjini, what? Jin Xiaojing, would you like to read what Anjini has on her paper? Anjini, you have to say it by yourself. Okay.
Next time.
Next time? No, this time. Come on. You're a big girl. How old are you? 5, 6? You can
3n plus 1 or
3n plus 1? What is n? Hmm? What's the answer? So, I see. So you're writing it down, right? You're saying this is summation 3 to the n over n factorial, right? And from n from what? 1 to infinity. What's that? Say it again. Your answer goes from 0?
Yeah.
Okay, fine. So n from 0 to infinity, 3 to the n plus 1 over n plus 1 factorial. Okay. Yeah, but so what is that? Do you recognize it? What is it?
E to the minus one.
E to the 3, right? E to the 3 minus 1. Right, because we don't have the 0, we don't have this, we're missing the 0 term, right? If we had 3 to the 0 plus this, then that would be e to the 3, right? But we don't have it, so e to the 3 minus 1. Okay, what about this one? Basically, same sort of thing. Who wants to go ahead? One more. I think you want to say. You don't want to say? Chen Ren Hao. Not exactly. E to the not natural log of 2, but because you have these negative signs, right? Negative, positive, right? So if it were all positive, then yeah, then it would be e to the natural log of 2. That's just like 2. 1 minus e to the natural log of 2. So, right, e to the natural log of 2 would be 1 plus natural log of 2 over 1 plus natural log of 2 squared over 2 factorial plus natural log of 2 cubed over 3 factorial plus full over 4. Okay. If you have 1 minus that, then you would get 1 minus that would be negative natural log of 2, negative, right, negative, right? It would all be negative, right? So it's not quite. Who can see it? It's easy, right? Yeah. So what we have is summation, right? Negative 1 to the n natural log to the n over n factorial from 0 to infinity, right? In other words, right, negative natural log of 2 to the n over n factorial. Right? So what's that? You know it. It's e to the negative natural log of 2, which is not negative 2, but 1 over 2. Right, it's 1/2.
但是它那个一改的话，就应该是把2的0次方变成0的几乘，但是分母不能为0。
Say it one more time, more slowly, or say it in English. No, you can say
y equals to 0 over
0 factorial equals to 1.
yeah, 0 factorial is 1. 0 factorial is 1. Thank you. Okay. Okay, what's this last one? Did anyone figure out the last one? Should I give another bonus point? Bonus point to the person who gives me the right number. Sine pi over 4 is it? Yes. Zhang Shiqi gets it. Right? Because you know what the sine is, right? Sine of x is, right, this x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus plus minus plus, right? Which is to say, negative 1 to the n x to the 2n plus 1 from n equals 0 to infinity over 2n plus 1 factorial. Right? So you recognize it, right? You're like, oh, look, it's got to be the sine. Right? And I should put the 0 here. And so you have pi over 4 to the 2n plus 1 is your x. Right? Pi over 4 to the 2n plus 1. So you end up with sine pi over 4. In other words, it's greater than 2. Okay. Okay. So this is just, like, are you able to recognize the series? Do you have some ability to play around with the series, basically? That's what this game is checking. Right? Do you understand? Do you recognize, do you see the series? Okay. Any questions? Okay. So okay. So okay. Another thing that you can do with series is evaluation of limits. So, for example, you know what this limit is, right? Sorry, as that goes to 0. What's this limit? You know it. What is it? 1, right? How do you know it? You can use, say, L'Hopital's rule on it, right? By L'Hopital's rule, this is the same thing as the limit of cosine x over 1 as x goes to 0. That's 1. Okay. So that's L'Hopital's rule. You take the derivative. If you get 0 over 0, you can take the derivative of the top over the derivative of the bottom. Okay. But suppose you don't know L'Hopital's rule, you can still say, well, I know about power series, right? And so you get x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus minus plus, etc. Everything over x, right? Well, that is the limit as x goes to infinity of 1 minus x squared over 3 factorial plus x to the 4 over 5 factorial minus x to the 6 over 7 factorial plus minus, etc. Right? As x goes to 0. Okay? And so that's 1. Right? And maybe that's a little bit more satisfying than the mysterious L'Hopital's rule. Right? L'Hopital's rule is like, cha-ching, and out comes the answer, and you understand theoretically how it gets there. But this, you really feel it. Right? It's like, oh look, you divide by x, you get 1 minus this, these guys all vanish, it's 1. Right? It really feels like 1. Right? The point is that this thing here is the power series expansion for sine x over x. Right? This is that. Right? So as x goes to 0, well, you get 1. Okay. So the book has a few for you to try. So exercise. Why don't you try this one? X minus natural log 1 plus x over x squared as x goes to 0. Okay, talk to somebody nearby and say what you got. Okay, let's do it. What's the power series for natural log of 1 plus x? Does anyone remember? We did this yesterday or the day before? Say one more time.
-1
Mhm.
to the x multiplied by x to the n plus 1 over n plus 1.
From n equals from n equals 0 onwards. Right? Okay, yeah, that's right. Okay, so you get right. So you get, I mean, that's to say, x minus x squared over 2 plus x cubed over 3 minus x4 over 4 plus minus x. So you take x minus that, right, and you get x minus that is going to be x squared over 2 minus x cubed over 3 plus x to the 4 over 4 minus plus, etc., etc. Right? Everything over x squared. Right. And so what's the answer? The answer is 1/2. Because you get 1/2 minus x over 3 plus x squared over 4, etc. And all these guys will vanish. Okay, another, maybe the last example. Sine x minus x cubed over 3 factorial over x to the 5th as x goes to 0. Oops, that's not right. It should be a plus. Okay, maybe +1 on the exam to the first person who gets it, but Wang Bo and Zhang Shiqi cannot play. You already got your bonus point. Ah, he's doing it. One over 5 factorial, yeah, detailerized it. ，Angie gets -1 for not speaking. Okay, so right, so you see how it goes, right? Sine is, remember, x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial plus minus blah blah blah. So when you subtract these things out, right, you're left with this. You divide by x to the 5th, you get 1 over 5 factorial, and then some terms involving x. Right? All those terms will vanish, and so you're left with 1 over 5 factorial. Okay. Okay, take a short break, and we'll come back.